In 7.1, we'll talk about how all circles are similar. Earlier in the year, we talked about what it meant for two figures to be similar. We discussed how if we could find a single or sequence of transformations which mapped one onto the other, which were a series of dilations, translations, reflections, and/or rotations, that the two figures would be similar. Well, we can actually show that any two circles are similar by finding a translation and dilation between the two. For example, in a general pair of circles, circle A to circle B, where circle A has a radius little r and circle B has a radius big R, we can show that the two circles are similar by finding the translation, which moves center A to center B. This is actually a vector AB. We're not going to go too in depth with vectors, but it would be essentially the horizontal and vertical movement between the centers. So I'm going to go ahead and write that down. So our translation coordinate rule would be the movement between the two centers. So this is going to be the translation from first center to the next. So from first center to the second center. And this would move the circles centered at the same point. And then we can dilate the circles to make the radii the same. And we're going to dilate the first circle by a scale factor of big R divided by little r, or known as the second radius divided by the first radius. So once again, our dilation factor will be the second radius over the first radius. Now, something important to notice. I know in the notation we're using big R's and little r's, but that doesn't necessarily mean big radius over small radius. It's always going to be the second circle's radius over the first circle's radius. So let's take a look at an example. Here we have two circles, circle A and circle B. We want to move circle A to circle B using a translation and a dilation. So the first thing we're going to do is we're going to move the center of A to the center of B. So by doing that, let's take a look at how much we would have to move horizontally and vertically. It looks like horizontally we're going to move 1, 2, 3, 4, 5, 6 blocks. So we're going to add 6 blocks horizontally. And vertically we're going to move down 2. So that would be a shift -2 in the y direction. This would make our translation vector x plus 6, comma, y minus 2. Now, our dilation scale factor would be the second radius divided by the first radius, as we had mentioned above. Now, once again, the second radius isn't necessarily always the biggest radius, as it is in this one. The second is always your second circle. So if we're moving from A to B, our second circle would be B. And if we count the original radius, it's 3. Then we're going to divide by the original radius of A, which is 2. So we would be dilating A's radius by a scale factor of 3/2. And now circle A is enlarged to the size of circle B, and thus has shown to be similar to each other. We're going to take a look at one more example of determining our translation vector and our scale factor. So here we have two circles, and our directions say to find the translation vector and scale factor, which translate from circle A to circle B. So circle A is our first circle, and circle B is our second circle. So to find our translation vector, we're going to move from A to B. So we have to think about how do we get from this point A to our new center point B. So it looks like I'm going to horizontally move backwards and then vertically up. So I'm going back 1, 2, 3, 4 spaces it looks like, so that's a -4. And I'm going up 1, 2, 3, 4 spaces. So it looks like my translation vector is going to be x minus 4 and y plus 4 for our vertical. Now the dilation scale factor will be the second radius divided by the first radius. Here our second circle is B. So our second radius will be the radius of B. So it looks like it is 5 units in length. And our first radius is the radius of A, which will be 3. So our scale factor will be 5 over 3. And this notation essentially just means a dilation of A 5/3. And there's actually supposed to be a circle here to indicate that we're dilating the circle. And same thing here. And this will equal circle B. But somehow those symbols just didn't make it. And that's it for notes.